Hi, Alvaro. Welcome back.
Hey, hello, Adam. Thank you so much for having me again.
Yeah, and I watched your live show about StackGres. So the first time there is something to see, not only to hear. It was a Quarkus Insights episode, and
Yes,
I have to find it. This was a recent one. It was in February. Quarkus Insights.
yes.
And we know the name?
It was about StackGres itself. I think it's 237.
What is StackGres? 237. 237.
Yep. 237. That's correct.
Mm-hmm. And, okay. And what you did is you presented live the Quarkus in native image as Kubernetes orchestrator.
Exactly, as a Kubernetes operator, right? So we use the StackGres, just to fill in everybody here in the audience, is basically a platform for running Postgres anywhere you want, where you have some Kubernetes or OpenShift, right? And the cool thing is that it's technically a Kubernetes operator, but it's all written in Java, powered by Quarkus. Actually, it's split into a few Quarkus projects. And they're all compiled to native thanks to Quarkus and GraalVM, of course, and distributed native binaries. So the end user just sees the binary container with a binary there, which performs as the operator. And during this Quarkus Insights episode 237, I was with my colleague Matteo, one of the main creators of the StackGres and programmers of StackGres, the lead technical person for it. And he also performed some live demos, which of course had some small nuances, but they were fixed live, so it was pretty cool.
There's actually no problem at all. He just confused the IP addresses.
Yep.
This is absolutely fine. I mean, this is okay. This is,
and then we had
it's even better because you see that it's live, you know?
Yeah. And then we had also a typo on a YAML that was typed live. So it was not anything with the software related, but just,
Yeah, you have to practice alpha next time, right? So
exactly.
Okay, but today is a highly focused episode on DB. This was the plan.
That's the plan.
Maybe before we start with the highly focused part, there was a question comparing CNPG to StackGres.
Yes.
And what is CNPG and what's the difference to StackGres once again? Maybe this would be also interesting for our listeners.
So there's plenty of operators actually conceptually similar to StackGres. Again, an operator, it's basically a specialized software that helps you run, in this case, Postgres on Kubernetes. Probably one of the most popular also is Cloud Native PG. That's CNPG. Cloud Native PG is a project by a company called Enterprise DB. And so, I mean, there's plenty of differences. There's different architectural choices. For me, the most relevant is that in StackGres, we decided to pick the most well-known, trusted, and deployed solution for high availability, which is obviously one of the most critical parts of the software, which is Patroni. So StackGres and all other operators use Patroni. CNPG decided to go with nothing, quote, nothing, which means, no, Kubernetes is enough for HA. I have a different opinion from a technical perspective.
But how it is possible just to use, so for me it's not even, so, I mean, without, how you could do this just with Kubernetes without nothing? I mean...
Well, I mean, technically Kubernetes behind the scenes has etcd, which is distributed consensus storage DCS, right? And you could leverage this to actually trigger a primary, secondary election. But actually, there's been a recent issue on CNPG claiming that there is a split brain risk. I mean, and a split brain is the worst thing you can happen on a database, right? It's basically...
you have two databases.
You have two databases, which are supposed to be the same, and some users write on one, some users write on the other one, and then you need to reconcile that manually, which is a huge pain in the best case, right?
Or impossible sometimes.
You lose impossible, or you essentially have to drop some data and you lose data. So it's a big thing, and I believe architecturally the only way to solve this is to use a tool like Patroni. And so,
but this is interesting because in order to use etcd for to preventing something like split brain, you will need to make etcd kind of transactional. Otherwise,
etcd is technically transactional, right? So that's the beauty of it, and it's exposed through Kubernetes API. It's not also you don't consume it directly; you expose it through Kubernetes API. But basically, my take on this is that there's there's a couple of things in IT that you shouldn't do by yourself. You shouldn't create your own solution by yourself, unless you are really an expert on this area and you're investigating new algorithms and you have like a very new innovative idea. And basically those two fields are distributed systems and cryptography. Like, I mean, unless you're a super expert in cryptography and come up with a new idea of a new algorithm, then yes, of course, you should do that. You should use some existing cryptography packages. The same happens with high availability in distributed systems. And in my opinion, that's the way to go, right? And if you try to roll your own algorithm for HA, yeah, sure, based on etcd, which technically is transactional in a distributed fashion, but still the algorithm is yours. You're using that as a building block, but the algorithm is yours. Then you can face problems. And the problem with distributed systems is that in most cases things work well until you're unlucky. And we prefer not to risk, and especially in a database, to be unlucky. So we want to make sure, and we ensure that in StackGres there's no risk for split brains.
Yeah, the interesting part, to give you an example, of a couple of years ago, more than 10, I was in a project when every 3 months the data became stale. And what happened was, it turned out that there was a very special night where 2 jobs run at the same time. And this caused a problem. But only then. Exactly. And they had something to do with transactions. So this is really hard problems to fix. But I'm just curious. So Patroni versus plain etcd. What algorithms we are talking about? Is like one is master and the other is follower, like the leader follower, or what happens behind the scenes? You know, why we need an algorithm at all? This is just interesting.
Yeah, so definitely you need an algorithm. Basically, what Patroni does, which again is the most used and deployed HA tool in the Postgres world, right? Battle tested for so many years. What Patroni does is, it does a lot of things. And Postgres is a primary replicas architecture, so there's only a single writable instance. So this instance, what it does, and actually Patroni uses etcd behind the scenes, but Patroni has a complex algorithm and a lot of battle-proven cases tested in production to understand what it needs to be done. But basically, the primary needs to acquire a leader lock. It's called a leader lock. And it holds this lock for 10 seconds. And every 10 seconds or less needs to apply to renew it. This is done through etcd. And if the primary cannot renew the lease lock or the leader lock, then it expires. And then it triggers an election. Again, etcd is used for the other nodes to compete to know which one is going to be the primary. And then there's complex logic there because, for example, if you're using a synchronous replication in Postgres, the replicas may be at different distances from the primary, and you want to elect, obviously, the most recent one, the one that contains the most data. And so at the end of the day, there's quite a lot of logic. Then there's a lot of circumstances where you may have partial partitions or partitions that shift over time. Node 2 can talk to node 3, but then the next point, half a second later, node 2 cannot talk to node 3, but rather can talk to node 1, and then node 3 can talk to node 4. Like, there's a lot of circumstances, and this is what proven algorithms solve already. And that's the approach followed by StackGres. So it's actually a bit surprising.
I get it. This is actually what Zalando did before, right?
Yes.
Exactly. Yeah, I get
Zalando,
it. Okay, this was
Zalando.
Okay. So this is just the Postgres clustering algorithm that we are talking about. I thought there's something more. What happened? Okay, and this was already interesting because years ago, it was, I think, before Corona time or something like this, we evaluated the Zalando and exactly what you talk about. So there were also cases where we could lose some data between, so there was not, there was always some windows. There was some critical, I actually forgot it's a long time ago, but, and of course, it's very similar to two-phase transactions. You have very similar problems in such environments as well.
Yeah. So Postgres actually supports 3 replication ways. You can use async replication, which by its nature is async, and therefore there could be a delay, and you could lose data if you promote an async replica. Synchronous replication, where there's almost a strict warranty that you will never lose any data, whatever happens, but then it's subject to latency problems. And your cluster may be much slower, so not most people do not use synchronous. And then there is a midway in between called semi-synchronous or group replication, where you wait until a few nodes have reached the replication stream. It's not pure consensus algorithm.
Quorum.
Or quorum algorithm. But if you use a tool like Patroni, which behind the scenes uses etcd or other DCSs, which actually enforce these warranties, then you have much stronger warranties. So most people with serious environments where they don't want to lose data, they use quorum or semi-synchronous replication. But if you're only on async, then yes, there is a risk of data loss. Typically, it's anyway close to zero because the replication lag on a properly tuned system is sub-second. And so you typically don't lose anything. But the best way to go is semi-sync.
And you can pick in StackGres which replication would you like to have, or you? Okay.
Oh, StackGres is super flexible. You can pick any of these three methods. You could set up cascading replication, which means you have a group of nodes and then another cascading from that one and replicating from that one. This could be even on a different data center or even on a different Kubernetes cluster for cross-region replication. You can create groups of replication like in a tree shape within your own cluster so that you can set up different nodes, different replicas for different purposes. For example, replicas for high availability, replicas for reporting, replicas for other kind of workloads. It's extremely flexible on top of this, yes.
Okay, and what's but there is a conventional setup because what we already discussed, you are shipping with best practices so what's the default?
Usually, most people tend to create a 3 or 4 nodes cluster, typically 3 node cluster with quorum replication, with semi-synchronous replication, which basically you write to 2 out of 3. And
but
then
you're
maybe
right.
cascading to the data center.
I would say it would be a huge effort to build it by yourself. Now I understand, if you would like to, this is, imagine just the tests. You need, timing tests, stress tests, and everything. This is almost mission impossible for a small company. So, it is possible, but you will have to focus on this the entire time, actually. This is what you should do and have, test suite. So I would say it would be a completely different product if you do it right.
Yes.
Yeah.
And then factoring
so now I understood it. Okay.
Everything else that it brings on the table, like also automatic backups, automatic monitoring, a web UI, a REST API, sharding, it's also included, hundreds of extensions. StackGres is 250,000 lines of code, Java code. That's not nothing, right? So
no, but there would be the algorithm would come on top of that, right? So there would be completely different. Okay. Now I understood. So interesting choice. I can only imagine licensing compatibility or something like this because to do something like this from scratch is huge effort.
It is.
Yeah. And if we had problem in projects, is always because of two-phase commit, distributed systems, timeout. Timeout is always interesting, Even in two-phase commit, if one resource doesn't answer, what do you do then? Can you assume that it's not done? You cannot say anything, actually.
Actually, one of the biggest problems with 2PC is the false positive. Is basically when you prepare the transaction first and the nodes receive it, you're good, and then you say fine, go on commit, and then the nodes commit, but then you don't know because that message of yes, I committed is lost, and then you have to have a mechanism to probe whether the operation was successful after a given timeout because you didn't hear back from a particular node.
And this is why you get the heuristic exceptions. And the heuristic exceptions were widely ignored in Java projects. Okay, this is just a heuristic, I don't care. And then it was, this is one project. So this is why I was so interested in the Patroni and consensus case because I wanted to deeper understand what's going on. But now I got it. And right choice. Just pick one which works. And otherwise, this would be crazy to implement. If you will implement it by yourself, this would be... not very good for the product, right? Yeah. Because if someone looks at the code, they say, okay, what's that? Why you did it? It's exactly if we would replace, in Quarkus the transaction monitor, we say, okay, we build our own transaction management in Quarkus. This also will require some explanations, I would say, in projects at least. So I will ask in my code reviews why you did it. There should be an easy answer.
Yes.
Pretty cool. So now this was my question regarding the 237 episode of Quarkus Insights. And what is ondb?
So, I'll try to make it the long answer short. But first of all, ondb means own your database. And conceptually, what we're trying to do is, so first of all, it's a new project from our company, from Postgres. It's going to be open source. It's not published yet, but it's going to be soon. And so our idea is that we went back to the whiteboard a little bit, and we were reflecting on why people pick Postgres, why Postgres is so popular, why people want Postgres. And there's plenty of reasons, but one of them is it's open source. It means you can inspect everything. You can see how it works. You can connect to your server, and you can do anything you want there. And you can install extensions, and you can install your own tools. And when you need to troubleshoot a problem, you can install your, anything that you need, GDB and debug Postgres, right? We need to sometimes do this with customers. And so if we look at managed services, which have already a significant presence in the market, even though most of our customers still run on-prem. They're large companies who run a lot of workloads on-prem. But if we look at the cloud landscape, we've got managed services, which all of them offer great Postgres options, nothing against. But you lost control. You can no longer connect to that server. You cannot inspect how it is. You don't even have access to the source code anymore. They are proprietary forks of Postgres, some of them closer to the original source code, some more distant. But in reality, you cannot even check your backups. Rule number one of backups, test the backup. Well, we cannot. In managed services, we cannot test our backups, our data. We need to trust that it's there and they work, and they do, right? But we cannot. So we've lost a bit this touch with our very original reasons why we want Postgres and open source, and we want to bring back this idea that it's our environment, our data, our sovereignty, and we can exercise that. But on the other hand, people want the flexibility and the extreme easy of use of managed cloud services. I want to click, and boom, get a Postgres cluster up and running, production quality, right? This is what we have done in StackGres, but it's specific for Kubernetes platforms. So we want the convenience of cloud managed services with the concept that you can run anywhere you want, on your own rules, on your own servers. You can inspect everything. So we want to both unite the worlds of the classical self-hosting, where you did everything by hand, it was painful, but you controlled everything, to the world of the conveniency of cloud services, where everything is automated and production quality and packaged and everything.
But in StackGres, the Postgres is still open source. This is not unmodified Postgres. Unmodified. So you already achieved the goal with StackGres already, right? Exactly. The only problem is you have Kubernetes.
Exactly. You nailed it. So StackGres fulfills this vision completely. You can run a StackGres anywhere you want, on any cloud, on-prem, anywhere. You have full control, pure Postgres, vanilla Postgres. You can inspect everything. You can install your own tools. It just requires Kubernetes. And this is a great thing.
But you could also test backups. You could do whatever you said. Yes. It is possible with StackGres. Okay, because I got the impression that this is like proprietary, which is not possible. Everything is possible.
Everything is possible.
On top of. Okay.
Look, when I talk to a lot of people, and people say, "Oh, I want to use RDS, right? Because Amazon manages it for me." It's like, yes, RDS is a great service. It is. But do you think there is some Amazon employee managing your server? No. It's obviously software. That software, they were pioneers, and they created this software 10 years ago, more than 10 years ago already. But today, 2026, this software already exists. It's a commodity, and it's open source. You can just use it. So absolutely, StackGres fulfills this vision. You can go, and even if you're like a UI person, you can go click, and get a Postgres cluster in literally seconds. And it's production quality, right? Of course, you can also automate with CI/CD pipelines, with GitOps and all that. But you said it very well. It requires Kubernetes, and we love Kubernetes. We have participated in the OK Data on Kubernetes community. We have promoted the use of databases on Kubernetes. And you know what? This is like the electric car. People either love it or hate it. There's no middle ground, or at least there's a lot of people who don't want this, or don't want this right away. So a lot of people do not want to run databases on Kubernetes. So again, because we came back to this whiteboard and redesigned everything, we were thinking, is there a way where we could use the StackGres experience without Kubernetes? Can we remove Kubernetes out of the equation? The first answer was no, this is impossible. Kubernetes actually provides us a great starting point, because it kind of virtualizes the infrastructure. We had experience in the past that every infrastructure is different, but Kubernetes virtualizes it behind an API. So apparently,
I thought about Kubernetes and about my opinion about Kubernetes, because I think what happened is it's exactly the same as enterprise software. So enterprise software and Kubernetes attracted very specific kind of developers sometimes. And in enterprise software, what I saw, there were kind of developers, and there was a stereotype who really loved, the patterns on abstractions and just, writing software and be like future-proof and everything is replaceable, but there were no real requirements. So they produce a lot of code without any added business value. And similar story in Kubernetes. I was in project where, they spent hours with YAMLs and generating YAMLs or whatever, and at the end of the day, it didn't matter because the same project could be run on Docker in one node and no one cared.
Yes.
And the problem is both were so convincing that I saw, a huge effort with Kubernetes. So in one project, we talk about serverless, and they told me, okay, they don't care about cost savings because they have an entire department who cares about Kubernetes. So, okay, this is strange. But and this is why. So Kubernetes is actually great technology if you would have your own cloud, and you have to have one. And I already thought about having a small cloud for me in my basement as well. Kubernetes, no time, but I will also implement it locally. But in most cases, for most projects, Kubernetes doesn't make any sense, especially not if you already have a real cloud like Azure or AWS or whatever you have. And this is the problem because it attracts developers who love to fiddle with YAML and forget about business logic. This is, and the same was true, and not in just the same was true with Java EE and before that with XML. I remember XML came out, so that and someone convinced a company to store. This you will love the story. There's a book, Java and XML at Java 1 2000, and short after that, a client called me. There was actually an insurance, and they told me that they store now in DB2 XML, and I say, why you do this? And if you think this is crazy, because the table has already the metadata, right? So there is a name and there's a type, and they store it in this XML once again. And the funny story is, a few months later, they had to buy new hardware again because, the database exploded. And if I ask, why XML, the answer was, because of XML. Actually, there was no answer. They just wanted to have it. And the same problem is with Kubernetes. So if you are reasonable, Kubernetes is way to go. But if you don't need Kubernetes, don't use it, right? This is what, how...
Yes.
You know what I mean? Mm-hmm.
So Kubernetes is definitely not the universal solution for everything, as some people like to paint it. And as usual, right? Your use case varies, your mileage may vary. So there is use cases for Kubernetes and uses for not Kubernetes. So we wanted to cover both grounds where we were only covering one. And we found a way. And it's a pattern that I'll blog about it one day, but it's what I call Kubernetes without Kubernetes, or basically chopping off the head of Kubernetes. Sorry about
Kubeless.
Yeah. Well, that's a good name, Kubeless. I like it. I may borrow it if you don't mind.
Yeah, you have it.
So the idea is actually pretty simple. Kubernetes is actually two things in one. It's a distributed orchestrator. It's something that allocates resources for your workloads. You say, I want to run these workloads. Kubernetes is like, fine, hold my beer, right? And I'll do this for you. And finds a node or nodes or whatever and creates everything and deploys the workload. So it decides. But the other part is, at the end of the day, Kubernetes is going to decide, okay, this thing is going to run on node A and this thing is going to run on node M, whatever, right? And then it calls to a component within node A and node M to schedule some containers. So we thought, what if we remove the first part, the orchestrator, and just go directly to a node and say, hey, I want to run a container here. And the software component that essentially runs this on almost all Kubernetes clusters today is called ContainerD, which is an API programmable container runtime. So it's something you talk via an API and run containers. Actually, this is what Docker does as of today. Docker is code, don't get me wrong, nothing against. It's kind of a shim layer on top of ContainerD. It has its own own API, which is the commands we're used to Docker. But then Docker talks to ContainerD. Actually, it's Docker client talks to Docker server, and Docker server talks to ContainerD. which containerd creates the containers, which is actually, but by the way, not directly run something like called runc, and then runc actually runs the containers. It's a bit of a long chain. But at the end of the day, what matters is that there is a component that is programmable and can run containers. So this is the part that we kept. So ondb is basically was many things at once. We can go on that. But the main component, the main idea is that I have a binary which unsurprisingly is written in Java with Quarkus compiled down to a native binary command line, which talks to ContainerD via its API. Actually, it uses the same API as Kubernetes. ContainerD has two APIs, CRI, which is a standard Kubernetes API, and its own, let's say, proprietary API. We use Kubernetes one. So we create pods without Kubernetes, just by having our own self-contained binary that actually also contains the installation, contains also ContainerD. So you download, basically the experience is that you download the binary, self-contained, is a basically curl pipe shell pattern, and then you have a command line. And this command line says, create a Postgres cluster here. Boom, and you get it, done. And you start from an empty Linux VM. No Docker required, no Kubernetes required, nothing. Just
why no Docker? But how you get the containerd?
It's embedded within our installation, and actually we make it run on a path that will not conflict with, even if you're running containerd because you're running Docker or something else. It's like a semi-random path. It will not conflict with anything. It talks over Unix domain sockets. It doesn't use a port, so you don't feel it.
So you will ship containerd with your distribution.
Yes, that is correct.
And so it will be Kubernetes also without etcd, right?
Yes, etcd is not required either.
So it will be like actually just containerd. So there will be no
containerd plus our ondb CLI, which embeds and talks to containerd.
Yeah, I mean, makes sense.
That's simple. So it's basically containerd daemon for our use case, and the ondb daemon. And the ondb CLI, which interacts to our daemon that talks to containerd that manages the clusters.
Why this ondb and not on app? Because it's nothing to do with DB. This could be actually interesting for everything.
This is a really interesting point. So, well, first of all, it's called ondb because we're focused on data. Well, first of all, because naming is hard. Second, because we are focused on databases. But you're not the first one. Not the first one telling me this. This could be a pattern for running everything, and you're 100% right. Still, our company focus is databases and Postgres in particular. So this is what we're going to do. But this is very relevant because let me expand a little bit on this. This is the basics. This is the main building block, right? That we have reproduced with Kubernetes does at the node level. But what about
Alvaro, just saying, you are a database company. But if you do this right now with Quarkus as an orchestrator, native image, and you can control the containerd in the pods, you are not far away of having a complete cloud. So I mean, if you what you can do now is you can deploy a small Quarkus Lambda-like things, which talk to your databases, and you have your own cloud. I would say this would be a huge opportunity. I know you have to focus, but I mean you have everything in place.
Well, what you're talking about is actually done also already.
Oh man. We have to talk more often. You know, you are shipping faster than our podcast episode cadence.
Well, you know, in the last few months, we have hired a lot of interns in our company. Surprisingly, they all have the same name, and they can work 24/7. So we're definitely shipping much faster than before.
Is it Claude or OpenAI?
Yeah, we call our interns Jan Claude Van Damme, but you can guess.
Okay, cool.
Yeah. So this component that actually ships next to the with containerd, we call it Slowney. Slowney comes from the mascot of Postgres called Slonik, which means a small elephant in Russian.
Didn't know that. Okay.
Yeah, that's an official name of this Postgres mascot. And so the component that runs next to it, it's called Slowney, also following the same same thing. But Slowney is then therefore node local. So when we install ondb onto a Linux box, which again is a curl pipe shell command, it's just one command, then what it does is prepare it to running Postgres workloads on it. And then you can use the command line to create a Postgres workload. But this is a single node. How do we create a cluster across multiple nodes? Exactly what you were talking about. We need some orchestration. So what we did is that we have created another component called Matriarch. The Matriarch, on an elephant herd, the eldest female elephant is the leader, and it's called the Matriarch.
Okay.
So we have created another component, which is another Quarkus application, unsurprisingly, which is called Matriarch. And Matriarch, what it does is that it connects to all the Sloanies and helps manage them. We use a very interesting technique here, which is what we call a reverse gRPC tunnel. So it's based on gRPC, right? And it's reverse because it's not the Matriarch who connects to the Sloanies to control them, but vice versa. It is the Sloanies that phone home to the Matriarch, say, hey, I'm here. Then they open a bidirectional channel, and then Matriarch can send commands, inverse commands. Once you open a bidirectional stream, it's just bidirectional, right? But what I mean is that first the Sloanie initiates the channel opening, and then most of the messages flow in the opposite direction. That's why we call it inverse. The advantage of this tunnel being inverse is twofold. On one hand, Matriarch does not need to know about all the Sloanies it's managing. They can come up and go as you wish. Otherwise, we'll need some config file or some inventory of the IPs and how to connect to all of those entities. It's much better to do the opposite. The entities know about the central place, which controls them all, the Matriarch. You can perform even SSL client certificate authentication if you want to. And then they get registered if they're properly authorized, obviously, to connect to this Matriarch. The second reason is that this works even across NAT environments. If the Matriarch runs in the cloud instead of your local environment, even if your Sloanies, your nodes run on-prem, on your laptop, behind firewalls, behind NATs, behind everything, as long as they can do an outgoing HTTP connection, which essentially all the world can do, then you can connect to the Matriarch, and then you have a bidirectional channel. So we can control them from the cloud. And this is actually what we're doing. We have a multi-tenant Matriarch that will be provided as a service.
But you need a seed at the beginning, right? So the Sloanies have to know where the Matriarch is starting, right? At the beginning. So this was always, the case in such networks. I actually aware of JXTA.
Yes.
Yeah, this is also that had seeds.
You mentioned once, yes.
Yeah, and okay. So if it is not a problem, right? So you have a list of possible IP addresses where Matriarch could work.
Well, actually,
right?
it's two things. So first of all, it will. So this Matriarch we will provide as a service. Mm-hmm. Will also be provided as an open source component for anyone who wants to self-host. But we want to make this insultingly easy. That's our internal definition, right? So Matriarch will provide as a service and will be the default URL. Otherwise, you can change the environment variable and then it will point to another Matriarch if you want to self-host, for example. But by default, ondb will point to the cloud-based Matriarch. So you don't need to do anything. And actually, we have developed on top of this a web UI, a web console. So basically, you enter into the web console, and the experience is as it follows as of today. Assume you have nothing. Just have some empty Linux VMs, Ubuntu, whatever, just create it. Nothing installed on it, right? You go to the web console, you log in with your social credentials, whatever you want to log in there, and you have like an empty screen. And then it says, add nodes. And then the web console already gives you the option to copy and paste a curl pipe shell command, which contains a token. You copy and paste into your empty Linux VM, and in around 10 seconds, that's what it takes. You will download ondb, install it, and connect to the cloud, to the Matriarch. Then you see your nodes already in the cloud console. And then from there, you can create a Postgres cluster and say, create a Postgres cluster consisting of 3 nodes. You select where they're going to run, a node A, B, C. And it also depends on the internet connection, but usually less than 10 seconds, you'll have your Postgres cluster up and running. And you will see both your resources, the nodes where you run the workloads, the Sloanies that I mentioned before, on your web console, as well as the Postgres clusters you are creating. So the experience is essentially 2 commands, or 1 command per node, and then 1 command or via the web console to create a Postgres cluster. And no Kubernetes required anywhere, but the same experience that the cloud vendors have offered with managed services. I would say even easier because they have become quite complicated. Even to create a Postgres cluster, you need to go through a lot of steps. this is a much more streamlined experience. But essentially, that's it. And you can run anywhere. You can run on your own servers. Could be on cloud, could be on-prem, could be anywhere.
So you could have 2 offices with 2 Postgres and coordinate them via your cloud, right?
Exactly. It's a cloud control plane for self-hosted, fully automated Postgres running anywhere you want.
Mm-hmm. This is like the how it's called, the VPN solution. We already talked about that. It's the same principle where you can reach a servers. Tailscale, exactly.
Yeah.
This is like Tailscale for databases.
For us. Yeah. It's pretty much the same. I just want to connect different computers and form a virtual network over WireGuard, but I want a cloud control plane that I don't need to worry about installing anything, managing anything. It just works. And yeah, very similar principles. We're heavily inspired by their user experience, not the technology or everything, but just the user experience, and works like this. So actually, ondb, at the end of the day, you have the web console, the cloud console, but you also have a command line. And the cool thing is that you can install the command line anywhere on your laptop, and then manage your clusters anywhere where they are, even if they're on the other side of the world behind the nothing and firewalls and anything. Because the CLI also connects to the cloud service and can see everything that you allowed it to see.
If I would have a JDBC connection, it would also go through the cloud service first, because I need the resolution. It has to know which database is up, right? If there's a cluster.
So this is a really, really interesting question. In the traditional world, let's say, even in the cloud managed services, what you would have to do is run your JDBC connection, your JDBC driver, from a place where you can directly access your database. If your database is running on Amazon Cloud, you'll need to set up an EC2 instance in the same VPC, right? And to be able to connect. That's still the case with ondb. You can obviously do this because you can always do this, right? But thanks to our tunneling technology, we are able to also tunnel the Postgres protocol so that you can run from anywhere in the world, even behind firewalls and not on whatever. We have a command which we call tunnel that actually ends up creates a local tunnel, and in your laptop or whenever you're running the CLI, and then you can connect from your laptop to your Postgres servers via JDBC as if they were local. Even there could be in a totally different network in different parts of the world. This goes through our service. It's all tunneled and is end-to-end encrypted. We cannot see anything at all. Your client connects remotely to the Postgres directly. We just pass bytes that are fully encrypted. We don't see anything. And you connect as if it were local. So yes, we have also achieved this. This could be conceptually similar to what Cloudflare has done with their tunnels product and other equivalent solutions. But I've never seen anything like this in the Postgres world. It is the first time that you can control your whole fleet from anywhere where you are, sitting on a plane with the Starlink connection at cruising at 30,000 feet. Your on-prem servers, your home lab Postgres. You can even connect via pSQL and run commands. So much that actually we have also added pSQL on the web console. It runs on WASM. So we compiled pSQL, which is written in C, to WASM, ran it on the web, and then it tunnels down to your servers.
Europeans will like your solution because you can run your Postgres database, wherever they like, office or not office, and there's still a cloud-like. And this can also bridge clouds and on-premises as well, and could also help you to have multi-stage environment, right? I could have test productions with connection, because the data is always the problem, but it would be more transparent experience. But what about stateless? If I have something like Lambda, I have still the problem, right? That one connection is one Postgres connection, so this doesn't change. Where I'm going with it, you need another product you can build on top of that data API, right? So you could have one additional pod, which running on your cloud, which offers not JDBC RESTful services. So you can have stateless connections, but this would be a completely different product. But you could offer this on top of that, right?
Yes, and we actually have to. You said two things before, right? One is that we could use this for all things that are not only databases, and even the same cloud control concept plane, right, could apply to non-Postgres workloads. But in reality, we're already doing this behind the scenes. For example, to support HA, if you create an HA cluster, we also deploy an etcd container co-located with Postgres because we need etcd because we use Patroni, unsurprisingly. And so Patroni requires some ETCS, and we choose an etcd. So we deploy also transparently for you etcd container, and we create an etcd cluster. You don't see it. It sits there. For taking backups, we also need to deploy other containers with backup technologies. So we're already deploying other workloads alongside our Postgres containers. And so if tomorrow we decide, let's supply something like, Postgres, which is a REST API on top of Postgres, for example, it would be just a matter of for us scaling another container. We all have the technology, the commands, we can send commands remotely. I'm not saying it's trivial, but it's absolutely doable. So yes, we can start layering things on top of this to add additional functionality for users.
And now imagine on your cloud, you have one Quarkus, let's call it API gateway, it's always on. And if I go there, it could route to Quarkus, which goes away, starts and goes, because Quarkus starts really fast.
Yes.
And then you have your serverless cloud.
Yes, we could do that to set up the tunnel. You connect to an always-on endpoint, and then set up the tunnel and connect to your own server anywhere. Yeah.
And then you have a huge refactoring because you have renamed everything from ondb to on run.
Yeah, naming is still hard, right?
Yeah. No, I'm just thinking because I like the concept, so how it works, and again, so you use the building blocks, and actually Kubernetes wouldn't help at all here, not at all.
No, not at all.
It wouldn't even work. I mean, I don't know. Maybe you could replace everything, but at the end of the day, it is easier just to. Right, I'm just because the entire networking distributed, so the reverse proxying and you could make it work maybe, but why? Right, this is the question.
Well, we have plans. So I mentioned that the component that runs on Linux that programs the containers via ContainerD is called Sloany. We right now we have Sloany in Linux. We call it Sloany in Linux because it's a Sloany that runs on Linux. We are developing a Sloany Kubernetes. And what Sloany Kubernetes does is a controller that you deploy to a Kubernetes cluster, talks through our tunnels to our Matriarch, right? But then, instead of talking to ContainerD to schedule a container, we'll talk to Kubernetes API to schedule a container. Conceptually, it's the same thing. API is different. Yeah. And therefore, we would unify under the same CLI, the same cloud console that we have, the ability to operate Postgres clusters in exactly the same fashion. But we will distinguish that the resource where you run them is either explicit nodes that you select from a list because you want to do it this way, or you say, I have a pool of resources, which is a Kubernetes cluster created there. And then we unify under the same umbrella a deployment model for Postgres clusters, whether it runs on Kubernetes or nodes, and it's your choice. We will even add clouds as a pool resource so that you don't even have to have the instances originally. Say, consider AWS as a pool for me. You have the rights to create EC2 instances on my behalf. Fine. Then we'll create the instances on your behalf, install ondb on them, which is actually trivial via the user data, and then connect to the cloud. And then you'll create a Postgres cluster. So it's a unifying model between and you said very well, it's like your own Postgres cloud. This is our definition, is your own Postgres cloud. That's what ondb is. But the difference now, you can run anywhere. You decide where your workloads run, on-prem, cloud, a mix of that, always under your control with the same level of conveniency that you get on a cloud managed service.
But the female elephant on Matriarch on Kubernetes, it will the pool would appear as one logical database, or could be multiple databases on the Kubernetes cluster?
Multiple.
Or either way.
The pool for me is a resource. We call them resources, right? So resources are either nodes where you install ondb and Linux VMs, or a Kubernetes cluster, or a cloud where you can create resources. You have permissions. The user gave you permissions to create resources from, and that's it. It says create resources, and then you create databases on top of resources. Postgres clusters on top of resources, as many as you want.
Yes, super cool. And what I do, maybe you are interested, has nothing to do with database, but it works perfectly well. I actually have already hundreds of automation scripts completely written in Java. So instead of using shell scripts, I'm using Java 25 source mode.
Yes, really cool.
And it looks like a shell script, so you don't even need the sh extension. It's just a file name without Java, without anything. You have the share bank at the beginning.
Yep.
And I have no colored output, everything actually, menus and whatever you like. And it actually it gets more and more powerful, because with Java it's really easy to have asynchronous HTTP calls or whatever, which is way harder with Bash or whatever. And the potential is way higher than I thought. So yesterday there was an AHEX Live workshop, and the attendees also like it. They were stunned actually what you can do with 30 lines of Java code. So because you have to know the instance main, there is no class, nothing, and you can have methods. And just saying, could be also interesting, to use Java for installation purposes, because what I'm doing, I have there are lots of skills they ship with Python scripts.
Yeah,
and the problem is, I don't know why. In my case, it always tries to install Python. It installs Xcode, whatever. Always triggers something, which is really annoying on my machine. And I look at this, and I migrated this to Java, and it was shorter and no problems. Because the cool story is you only need Java 25, and Java 25 to install. It is crazy easy. It is like double click, or you just say unzip from command line. But it is way easier than Node.js or Python.
Oh yeah.
And then you can automate everything without external dependencies, and I actually underestimated how powerful this is, because I still had some shell script in, my clients' pipelines and so forth, and I just did it for me, everything in Java. But now I'm thinking I will actually do it in real-world projects as well, because there are no downsides. And I put the one repository is called Zeets. If you go to my GitHub, you will find this is incomplete scripts, is like Zark argument parsing, or menu. Or a clipboard stores clipboard to a file, which I use frequently, just starting points. And there are some more sophisticated. One is, for instance, ZWS. What it does is it is built in web server, which starts the browser, and I can implement web components, and it works surprisingly well, because Java ships with HTTP server built in.
Yes, of course.
Yeah. And just telling you, think about this, because if you install something, it could be if there is, maybe it is easier to install Java first, Java 25, and then have the entire automation in Java. Just would be interesting, think about this, because this is now my experience. I just use it everywhere. And I have a project, very new one, which could be interesting. It's called AI Rails. So what I do, I published skills for BCE, Quarkus, and for diagramming, for documentation as skills. And to install that, I actually have locally a JavaScript, Java 25 script, and we'll also do this with that, because it's so easy. And I think we'll push it more, because the potential is huge. And if I show them to Java developers, they say, okay, strange. I show them the code, and it's very, very short. It's just with Java 25. It is beautiful, actually, and could be interesting for you. Just think about this, what it could do, because I would be really interested in your opinion, because you have a product and you have a Linux experience, whether there is something to it, to use it for, dependency-free installation.
Yeah, super interesting. I agree with you. I also underestimated this and saw it like, oh yeah, it's cool. This is good for beginners and all that, but didn't see the opportunity as a scripting opportunity. Really cool. There's one area where I believe we could use it. I'll explain you now. But let me highlight. There's a big problem with this approach. Let me be very clear on this. There's a big problem, because this essentially becomes scripts, right? And they're written in Java. So you would naturally talk and say, this is a JavaScript, and it could be understood totally differently.
Yeah, we have to call it differently.
Yeah,
but
because otherwise people will think this is JavaScript, and it's a
ondb script. ondb script.
ondb script. There's one area. Well, obviously, I was joking. There is you can say JavaScript within space in between, but it's a bit long.
Yeah, this is what I do. Yeah. This is just my joke. I just call it that way. But I send you the link to the chat. So there are lots of they get more and more. And another thing is, maybe it's already done, but is you could expose the Kubernetes Quarkus StackGres orchestrator as MCP. There's almost nothing to do with a view annotations, and you are done basically. And then expose it read only to whatever would like to listen. And I think with an agent you get cool insights, what your cluster is doing and so forth, and you get additional UI, agentic UI. And as a UI, I don't know whether you are aware, there is a Goose, and Goose is agentic standard UI, which belongs to Linux Foundation, and it becomes the standard. It was donated by Block, and it looks nice. And you are a Linux guy, and this is standard Linux Foundation, and you could use this to show how it works because it is already built in. You can have whatever models you like, local or not local. It looks like Claude Desktop or a ChatGPT desktop app or something like this. And it could be interesting to you because it's already part of Linux.
Yes, that sounds great. I'm gonna definitely check it out.
This was the MCP, and what I also doing is almost done. We'll publish it very soon. It is Postgres, but it's actually JDBC MCP, a very simplistic Quarkus MCP server, which exposes Postgres database, the metadata, as via JDBC as MCP, because then I can use my skills to generate the JPE persistence layer automatically. And there are lots of MCP servers, but I don't trust them because, this is some binary code. There is nothing from Postgres, interestingly. There is no Postgres MCP, which I was stunned. There was one from Claude, but it's no more maintained. And I implemented it like 2 classes, 5 methods, and it works beautifully. And I will do this and just queries because updates are a little bit, too dangerous. And I think this is also good practice to implement MCP by yourself, because you have to trust it. If you pick something from the internet and LLM can discover some whatever, it is really dangerous.
Yes, MCP servers can be dangerous. You cannot trust them blindly. So this is kind of the approach of this nanoclaw, right? That kind of programs itself. In this case, you program it, but at least it's for you, and that it's it's doing what you want and nothing else.
And I will maybe do this also, Graal VM image, that it can be started from the agent and it goes to Postgres and incredible.
Makes sense. Indeed.
And if you have already the Jean-Claude Van Damme in your team, you should absolutely try the skills from AI Rails, because what they do, no kidding, if you activate them, they create more or less code which I would write. This is I give you this in the chat.
That's really high quality code already. Then
there's almost no code. I try to delete as much as possible, so there is actually no discussion. We say, okay, look, this is the minimalistic Java code. So and
very nice,
cool. Obviously, I will have to reinvite you back to talk about ondb if it works, and maybe after rename, not ondb, on run or on app, on service.
The next step, right?
The next step,
There's obviously things coming after that in our roadmap for the, actually it was planned for the next year, but things are accelerating. It will be towards more of the second half of the year now. But there's plenty of plans afterwards. Let's keep it as this right now. But yes, there's more surprises coming down the road based on this architecture. You are absolutely right. We can do more things. Even much more.
And I don't know what is in your case, but I have more and more idea and less time. This is some crazy times nowadays, right?
It is the main problem. It is the main problem.
And the podcast is really bad because in discussion with you triggers 5 other ideas which I would really like to implement. But I could do this, right? But my clients don't care that much sometimes about my scripts, for instance, right? So it's okay, it's nice, but we need actually this. Okay, cool. Where people can find you? Maybe ondb, there's nothing, right? So you heard
ondb is not public yet. It will be probably in mid-April. We're targeting this date. Let's hope that we will make it. But if in the meantime anyone wants to start doing a private beta testing, more than happy. People can reach me out on Twitter, LinkedIn, starting from our website ongres.com. And just ping me. I'm easy to find. If you look for Alvaro Hernandez,
Alvaro Hernandez or AHT, right? So
AHT.es. That actually is my personal website.
AHT.
It is the easiest find to find. It's super easy. There, my LinkedIn, Twitter, everything is LinkedIn. LinkedIn too. So if anyone wants to ping me and try this and give opinion, early feedback, more than welcome. I'll be glad to help with onboarding. And please reach out to me. AHT.es. That's the starting point.
Yeah, thank you a lot. And see you next time.
Thank you very much. See you next time.